Hey, what's going on, Hume 2? I first want to congratulate you. You've made it to the end of the unit. After you conquer compositions of transformations, it's just a study guide and the test. So congrats on making it this far and almost finishing trimester 2. So congrats. Compositions of transformations. You're not really learning anything new. It's kind of putting all the information you've learned so far together into one nice compact action that you're going to take here in a second. So first, what is a composition? A composition is when you combine two or more transformations together. So it's really important that when you hear the word composition that you think, oh, didn't mean to do that. Why don't we get the marker going? That you think, when you see composition, you think combination, okay? It's really important. All a composition means is I'm going to do more than one transformation to the same point or group of points. So let's look at the notation, how it's going to be written. Composition notation, they can look like this. Now when you see this, that little circle just means composition. And you've seen this, you know it's a translation. And this means rotation. Now you always go from right to left, alright? It's not like reading a book where you go left to right. With compositions, you start all the way at the right and work your way back. So what are we going to do first? First, we do the translation. And then we do the rotation. All right. Let's look at number 2. All right, so if we're starting at the right and working back to the left, first we'll do the reflection, and then we'll do the dilation. From teaching this last year, the number one mistake I saw when students did compositions was they went left to right. So it's really important that you get this down right now. And so from here, the most you'll ever see is 3. So number 1 and number 2, we saw 2 transformations in one composition. This is as hard as it's going to get. They'll put 3, but we're still going right to left. So first, we're going to do the rotation. Then we'll do the reflection, and then we'll finish with the translation. Okay? So if there's anything that you take from this first page is that you start on the right and work your way back to the left. Alright? Let's look at some example problems of how this works. It might look like a lot, but it's actually very simple. Alright? So let's look at example 1. And I think it's really useful if you draw these tables like I have them in the notes, because it'll keep your thoughts organized. So it says the point 3, -2 is rotated 90 degrees about the origin and then dilated by a scale factor of 4. What are the coordinates of the resulting image? Now here, if you see, it told you what to do first. It says that they want you to rotate by 90 degrees and then dilate by a scale factor of 4. So in some examples, it'll be written out in language for you. You just follow the language they give you. But down here, that's when you use the right to left. So for number 1, they wrote it out, so let's just follow what they said. In this first part, you're at the original point. Our original point here is 3, -2. All right? And now we want to rotate this point by 90 degrees. Now, if you remember, the rule for 90 degrees is we have x, y, and it becomes -y, x. So we take our y, we change the sign and move it up front. So now it's 2, and our x just goes to the back, and that's 3. Now here's the key. For the dilation of 4, we do not go back to the original point. We keep going with our new point, all right? So we dilate this point right here, 2, 3. So we're going to take 2, 3, and we're going to dilate it by 4. And what are we going to get? What's 2 times 4? It's 8. What's 3 times 4? It's 12. So our final answer is 8, 12. All right. So we do our first transformation, and then whatever answer or point that we get, that's what we move on to the next step with. All right. So example 1, having it written out in English for you. Example 2 is when they give you the actual notation. So let's take a look. It says find the coordinates of the image of 2, 4 under the transformation, and they says a reflection, lowercase r, in the y-axis, and a translation 3 comma negative 5. So we have to figure out what's going to go up here. Remember, with this notation, we work from right to left. So what are we going to write up here? We're going to write the translation. Excellent job. So it's going to be 3 comma negative 5. Which means up here we write reflection in the y-axis. Now that you filled that out, it's just a matter of doing the transformations. So we have 2 comma 4 as our original point. Awesome. And now we need to translate it by 3 comma negative 5. So we know that this is for the x, so we do 2 plus 3, that gives us 5. And we do 4 minus 5, which gives us negative 1. And then we take this point and we want to reflect it in the y-axis. Now if you remember, a reflection in the y-axis, I'll write the rule down for you. After you reflect in the y-axis, all we do is we negate the x, or we change the sign of the x. So we're just going to change the sign of the x in this one and leave the y alone. So our final answer will be negative 5, negative 1. I got ahead of myself there. And that's it. That's your final answer. So if they use notation, just think right to left, and you'll be good to go, and then just work your points through. Now let's look at example 3. Holy cow, Mr. Elizondo, you got to be kidding me. It's actually a pretty simple problem, and I think you'll see once we get going that it's not too bad. This is a perfect example of one of the 4 or 6 point questions on the Regents, and this is going to show you how easy it is, and these are going to be points you're definitely going to get. And so they said they gave us these coordinates, A, B, C. A is 1 comma 2, B is 0 comma 5, C is 5 comma 4. And it wants us to first draw and label A, B, C. So let's go. Here's 1 comma 2, that's A, and we'll write A right next to it here. That's A. B is at 0 comma 1, 2, 3, 4, 5. That's our B. And C is 5 comma 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Alright. Yeah. And you might think it's crazy that I'm reviewing graphing, but it's really, really important because I've seen students lose points on graphing parts of a problem like this. Alright. And they want us to work our way through these steps. Now let's look and let's figure out if this is more like example 1 where it gives you the order or if it's example 2. So it says that step B, they want us to graph our new points after this translation. Then we're going to reflect it in the x-axis. That's what C says. Graph and state the coordinates after reflection. And it's saying an image of these points. You see how it's moving down? So it's giving us the order. So the first thing we want to do is translate by negative 6 comma 3. What's the next thing we want to do? It says step C, we want to reflect in the x-axis. So here we're going to reflect in the x-axis. Remember, reflection's the little r. And then D says reflect in the origin. All right, this is important because you've never seen that before. If you see reflection in the origin, what that means is a reflection in y equals x. So super, super important. If you see reflection in the origin, you think reflection in the line y equals x. And the table I already made was like this because we have points A, B, and C. So let's put those points in there. We have point A, which is 1 comma 2. We have point B, which is 0 comma 5. And we have point C, which is 5 comma 4. Now I'm not going to ask you for this example, we're not going to go through the graphing of each one of these images. I feel like you can do that. What I care about more is just the math aspect of it. I just wanted to review the quick graphing for our original image. I trust that you can graph the rest of the way through, but of course, if you have questions, ask Siegel or myself. So let's just work on these right here. So let's take point A. We want to take the x, which is 1, and subtract 6. So our new point will be negative 5 for the x, and for the y, it'll be 2 plus 3, which is 5. My suggestion would be to go through and do every column first. I wouldn't go straight across because it might get a little confusing. Same thing for B. We're going to take 0 and subtract 6. So now we have negative 6. Oh, sorry about that. Let me undo that. We have negative 6, and we have 5 plus 3, which is 8. And then we have 5 minus 6, which is negative 1. And 4 plus 3 is 7. Awesome. Now I move on to the next column. And this one, let's do in green. Let's add a little color. What do you say? So if you remember the rule for reflection in the x-axis, I'll write it up here. All right, when we reflect in the x-axis, we change the sign of the y. So we just flip the sign of that y. So here the x will stay the same, negative 5, and the y changes. So that 5 becomes a negative 5. Here the x stays the same, so we have negative 6, and the y changes. So now we have negative 8. And then here the x stays the same, so we have negative 1, and the y changes. So we have negative 7. Simple, right? And then finally the easiest one. Remember, when you reflect in the line y equals x, which is the same as a reflection in the origin, all you do is just switch the order. So in this case, this one's going to stay negative 5, negative 5. This one becomes negative 8, negative 6. And this one becomes negative 7, negative 1. Normally, if it asks you to graph all three, you'd graph this and label it the way it is right here. And then you would go through and graph this set of points and label it with the 2 dashes. And label this set of points and label it with the 3 dashes. What I care about is the math. So we won't review the graphing, but just the math. And ladies and gentlemen, you have learned everything you need to know about compositions. If you can do this problem, you can do any problem they will give you on a Regents exam. So, with that said, that's it for Chapter 8. Go ahead and finish these notes, finish the practice problems, do the study guide, pass the test, and you are done with Trimester 2. It's been a pleasure, and I will see you soon.